Okay, well, let me introduce myself. My name is Michael Price. I am the C++ Developer Cloud Product Manager at Microsoft. And you're here for my talk today on reproducible developer environments. So the structure of this is there going to be some more higher level thinking about what developer environments are and what the problems are. And then we're going to show, I'm going to show two different solutions, one by Microsoft and one by GitHub. We're going to get into the details of those in the later half. So, and there should be at least one interesting thing, hopefully, in the demos that you'll see. Okay, so some front material. Welcome everyone to CppCon 2022. We're almost done, but we still welcome you. If you have anything related, anything for any of the Microsoft folks that are here, questions you want to ask about products, you can find us on the Visual Studio Discord channel. If you're having trouble finding that, you need to find the directory channel in Discord, and that will give you instructions on how to get connected with these special interest groups like Visual Studio. The other thing I want to point out here is that Microsoft runs a survey every year at CppCon, and your input is incredibly valuable to us. We do something at Microsoft and have been doing it for a few years called customer-driven engineering. And it puts the customer's needs first, right? But in order to know what those needs are, we need our customers, or even not our customers. If you're not a Microsoft product user, that's fine too. But we need to know what you want, right? So it's important for us if you fill out that survey. And there's a website link there. And if you prefer QR codes and the like, if you're in the room, I have a piece of paper in the back on that table over there that if you want to scan the QR code when you leave, you can get to the survey that way too. Okay, one last front matter slide. We have a lot of talks from people at Microsoft here at the conference. Most of these have already been given, so if you're seeing this online later, feel free. I encourage you to go check out these other presentations by Microsoft employees at the conference. This is the last one of ours today on Thursday, but we have 3 more tomorrow, including one of mine in the morning, bright and early at 7:45 local time here in Colorado. That's an online-only talk. And then, of course, we have a talk on Visual Studio 2022 and what's new in that. And then Herb's closing keynote on C++ complexity. Okay, so let's get into the material. So this talk is about reproducible developer environments. So we need to think about, okay, what is a developer environment? Like it seems like it's an obvious answer, but we need to think more structured about it. And you'll see why we need that structured thinking later. So what are some qualities of developer environments? So I'm not going to say these are the only qualities, right? But these are just qualities that I'm calling out for the talk. So a developer environment has an affinity, right? So there's no such thing as a developer environment to rule them all, right? Like there's no developer environment that can compile and build and test every project that you can conceive of, right? They have some affinity to some set of projects, right? It may just be a single project. It may be 10 projects that are related, or maybe just 10 projects unrelated that your company has you working on, right? But there is an affinity for your developer environment and projects. Developer environments are built on top of some platform, right? So in the case of like Visual Studio, it's built on top of the Windows application desktop platform, right? If you're looking at something like Visual Studio Code, you might argue that that's actually built on a web platform, right? And there are other developer environments that are built on top of browsers, the environments that browsers provide, the platforms they provide. You could say there's developer environments who are built on top of a platform of a cloud provider, right? A developer environment has resources, right? The whole point of having a developer environment is you want to do things. And very often you want to do very specific things, right? So clearly you need some computation power, right? You're probably going to need some memory. You might need some hard disk space. But you might need things like specialized processor units, right? You might need an embedded device to be available to your developer environment. Those are what I mean by resources being available. And developer environments don't exist in the wild, right? You don't go into the forest and you find a developer environment that suits your needs, right? These are things that are configured, right? There are some set of steps where we take the platform and we build the things on top of it, right? And we configure our developer environment. And the last I have here is interactivity. A developer environment that you can't interact with is not very useful, right? And I think that this particular quality is something that differentiates it from continuous integration environments, right? Because there is some interactivity with continuous integration, but it's not the same kind of interactivity you have with a developer environment. Now, that's not to say that one system can't be both a continuous integration environment and a developer environment, but the needs of them are separate. Okay. So now we have an understanding of some of the qualities, what makes a developer environment a developer environment. We need to talk some about the problems. So every year, we're gonna take one step back from what are the problems, and we're gonna talk about why the problem, right? Or how the problem. Every year, the ISO C++ Foundation runs a survey. And every year they ask a question of a series of topics. Okay, is this thing a major pain point, a minor pain point, or not a significant issue for you? And it's a whole long list of things, right? Every year, developer environment issues, setting up a development environment from scratch, a compiler, build system, an IDE, etc. It ranks in the top 3 of pain points every year, okay? So I'm gonna do a little survey for the people here on site. Feel free to participate if you're online as well. You can just yell it out too. You don't have to take turns. What's the percentage of respondents do you think say that this is a major pain point? 90%. 70. You're probably saying that because it's a major pain point for you, right? Kind of skews your perspective. It's 28%. So if you had an answer in the room, feel free at some point in time near the end, at the end of the talk, to come get a free mug, a free Visual Studio mug. There's also stickers if you want a Visual Studio Code mug. We ran out of those, but you can make your own with a sticker and a Visual Studio mug. There's lots of stickers over here. Okay, so 28%, not a lot, but that's also the people who say it's a major pain point, right? It's got to be pretty serious. But almost 30% people having a major pain point for this, that's something. Okay, same thing, just yell it out. What about minor pain points? What percentage do you think said it's a minor pain point? 50, 60, oh man, this is a good crowd. Not quite, but it's still really high. 43% said this is a minor pain point for me, right? So, we can then deduce what the third one's going to be, right? It's 29%. Okay, so if you look at those, 71% of the respondents said that this is a pain point for them. Okay, almost as many people said it was a major pain point as said it's not an issue for them. Right? So we know that this is a big problem. In fact, there's only 2 other problems on the survey that have numbers like this. The first one is managing your library dependencies. Kind of tied into this too, and the second one is setting up a continuous integration environment. Go figure, right? A lot of common things in here. But these are the big problems in the C++ ecosystem, according to you all. Right? But now why? Why is this a problem? Why is this so painful for people? So let's talk about that. So there's going to be a list of things here, okay? It's not necessarily exhaustive, but it's a list. Procurement, okay? What I mean by this is I need a system to do my work. okay, how do I get it, right? If any of you work in corporate, large corporate environments, it's not uncommon for you to have a need and then, well, you've got to either wait for your tech refresh, which is going to happen in 6 months, or if you really need it and can justify buying it now, you buy it, but you got to wait on it getting shipped, and then when it gets shipped, it goes to IT, and then IT images it, but they have a backlog, so it's not going to be for a couple more weeks, right? It's a major pain to get access to the resources that you need. Misconfiguration. So whenever you go and create a developer environment, usually there's some set of instructions or a document that walks you through the process of getting it configured. But different people can interpret those instructions differently, right? And it's very easy to get it wrong. I installed the wrong version of this tool, right? Or even worse, maybe the documentation is not correct anymore, right? And oftentimes, you may not realize you have a misconfiguration until months and months and months, maybe years later. And then you're like, this has always worked. Why doesn't it work now? Well, you just ran into that one corner case. Fragility. So one day your system is working, everything's fine. The next day you come in and it's broken. And you have no idea why, right? Sometimes it's the operating system got patched underneath you and broke one of the tools you needed, right? Maybe it is you installed a trial piece of software and the trial expired, right? Developer systems are fragile, right? When they break, it causes lots of problems, and they break often. Genericity. This ties into that affinity quality that I was talking about earlier, right? If you are supporting 20 different projects, and those 20 different projects all have different requirements, there's a good chance that you're going to run into conflicts, right? I can't support project X and project Y at the same time, but I have to, right? So then you're stuck with a hobbled developer environment. It doesn't really do the thing it's supposed to do because you're trying to serve all purposes. Permanence. This ties in some to fragility. So who here or online has experienced a situation where, well, I really want to try out this tool on my developer environment, but if I install this and it causes it to go down, I could really be in trouble for like a week, right? Trying to get my system back. Yeah, people have experienced this, right? So what do? You don't do the thing, right? Because if you do the thing, then you'll be stuck. So you don't do the thing. This slows us down in improving our processes, right? And adopting new tools. And then inconsistency. So this is kind of like misconfiguration, but not quite, right? So like, say that one developer has this tool installed, and that's how they do diffs. But then another developer on your team uses a different tool to do diffs, right? And now there's a problem and you need to help, right? Oh, well, I don't use that tool. If you will install that other tool, I'll be able to help you, right? We shouldn't live like that, right? Okay, so these are some problems, right? These are some of the reasons why developer environments are hard. So we want to talk then about, well, so somebody comes to you with a solution to your developer environment woes, right? How do you evaluate whether or not that it's good for you or for your company, right? Do you just kind of like eyeball it and be like, oh yeah, I guess that sounds good, I'll try it, right? Probably not, right? But what I'd like to do with this talk is to sort of elevate this process to something that's more structured, with more thinking about the problems that your developer environments that you're trying to solve for your developer environments. So there's going to be 10 different criteria that I'm going to list here. They may not be all the criteria, right? But I'll get to the flexibility of this technique in a minute. Okay. Is the system reproducible? Which means that if I take this set of inputs, when I go to create one, do I always get, for that same set of inputs, do I always get the same output? Right? that's reproducible? Or if someone else takes the same set of inputs, do they get the same output? Purpose-built. Okay, how many projects does your developer environment support? Okay, is it 1? Because that's great, but not realistic sometimes, right? 3 or 4, okay. But again, if you're doing 20, you're in that zone where things are going to break. Managed. So especially for folks who exist in a large corporation, managing your developer environments is important. It's critical, right? Your IT or your dev infrastructure group want to make sure that your systems are secure and that they're not violating any policies from the company that the company has, or maybe even government regulations, right? Very critical. Is it available? Meaning, can you use this developer environment whenever you feel you need to? Right? I put an airplane here because can you use your developer environment on an airplane? Can you use it without an active internet connection? These are the types of questions you might want to ask and have answers for when you're evaluating solutions. Isolated. So the concept behind isolated is if I'm messing around with my developer environment, are there any observable side effects in other people's developer environments? Okay, the classic example I can think of here is you've got a bunch of users using the same shared server to develop on, right? One user runs some process that fills up the disk, right? Now, all your other developers that are using that same system are out of luck, right? Is it customizable? This sort of it goes against some of the other stuff, but like we're individuals, developers are individuals, we have our own tastes, right? So like, can a developer install their favorite editor plugin and not, cause a chaos in the system, right? I'm a VI guy, I like a VI plugin. Maybe somebody else likes Emacs, right? We already identified that this can be a problem too, right? But this is a part of a solution that you should consider. Is it documented? And how well is it documented? And is the documentation kept up to date? The pinnacle for documentation for me is that it's executable, right? Your documentation is something you run to create your developer environment. That's like the top of the heap for me. Is it versioned? As time goes on and you're working on your product changes, right? And inevitably, the requirements of your developer environment change too. And those two things match up to each other, right? You need a specific version of your developer environment for a specific version of your product, right? Classic example, what compiler version are you using? If you go to try to compile an old version, you need to use the old developer environment. Procurable. How long does it take to go from 0 to working? Right? Is it a week? Is it 3 months? Is it a few seconds? Right? And responsive. If you have a solution that you're typing, type, and you don't get response back for 10 seconds, that's a negative for a solution, right? But if it's instant, great. Okay. So I'm about to show you, let me take one little sip of water, throat's getting dry. I'm about to show you my own personal, rubric, or a rubric is a way that you evaluate something, sort of a set of guides to help you evaluate something, for a scorecard for your developer environment. I'm not going to go through each one of the things on these slides, right? The important part of this slide that you should realize is that I've made the rubric, right? That's the important part. For your systems, you should make your own rubrics. Now, I know that every single person is reading the actual items on there. That's not the important part. The important part is that you have a rubric, right? This just happens to be the one that I constructed for the purposes of this talk and how I see the world, okay? So I've got different point values assigned to different sort of things, aspects of the solution for all of these categories. Right? Some of them build on top of each other, right? And you'll be able to get the slides later from where we post the slides as well. So if you care about the details here, you can always go back. Okay. So here's an example scorecard for a fictional company, Contoso. Contoso is what you think of, oh yeah, you have a procurement process, you get a desktop machine, it goes to IT, they image it, they give it to you. Then you have to set up additional stuff, right? So, there's a few things that it's really high score on, a few things that it's really poorly scored on. It's really highly on the managed side, right? Not really versioned at all, right? Documented, yeah, there might be a document describing what you need to do, especially for the IT folks, right? It gets a score of 14, okay? We have no basis on which to judge comparatively how good 14 is, but we will later. Okay, so we're a little bit in. I can take one on-site question about the stuff I've presented so far if anybody has a question in the room. If you have online questions, we're going to get to those at the end of the talk. Okay, nobody has a question. That's good. Okay, so we're going to go from higher level thinking about the problem to, okay, here are some solutions, right? So the first one we're going to talk about is Microsoft DevBox. So who here has heard of Microsoft DevBox? A few people. Okay, I'm not terribly surprised, but so Microsoft DevBox is a solution that Microsoft is currently in public preview. We announced it at the Build conference this spring. It had a private preview period where you had to sign up, but as of September 1st, it's in public preview. And I'll talk some more about the public preview at the end of this. So what is Microsoft DevBox? So Microsoft DevBox is designed to empower your development team to manage the things that they are the best suited to manage, but also still give your IT and dev infrastructure teams responsibility for managing the things that they are best at managing, like OS patches, policies, things like that, okay? So basically what it is, it's a VM that lives out in the cloud in Azure. It's built on top of Azure. And it's a VM like any other. You can install whatever workload you need to on this VM, right? And one of the key features of this is that it makes it so that you can just make another one or another one. You can make as many as your team thinks that you need to make, right? You're not constrained to having the single one developer environment that you must keep in working state, right? If something goes wrong with the one you have, you just spin up another one. And even better, you can actually set up different images for different roles on your team, right? So maybe you have designers in addition to developers, and they use a different set of tools, right? You can have an image just for those individuals that they can then go create machines to work with your project. And the IT folks love it, right? It lets them do all the stuff that they would normally do to manage systems in Azure to keep them safe, secure, and compliant with everything that they care about. So this is how an example of how different roles would sort of view and use the DevBox infrastructure. The IT and dev infrastructure teams, set up network configurations, connect the dev center to your actual physical network or existing networks in Azure, so you have access to the resources that you already are using. They set up security. They can set up policies. They can deploy OS patches and things like that. Your dev teams, particularly usually it's going to be a dev team lead, but you may open it up if you want to everyone on your dev team. They're responsible then for sort of managing the images and the tools and stuff that are on the developer machine, where it belongs. They're the people that are best suited to know what tools are needed. And then the individual developers interact with this through a very simple, easy to use portal. They don't have to log into Azure to deploy a virtual machine. And we'll see what that looks like in the demo. So, it's not free, right? If you're expecting a developer environment for free here, I'm sorry I had to disappoint you. But there are ways that you can control the costs, right? So the way that costs are calculated for DevBox is that when you create a new VM, not the image of the VM, but a new VM, you pay for the amount of storage that you're using the whole lifetime of the VM, of the DevBox. But you only pay for computation fee while the DevBox is running, right? This is different than like a subscription model that we have other Microsoft products that do subscription models for systems in the cloud, right? You only pay for what you're actually using. And during our public preview, which I said started on September 1st, you get a certain amount of time and space on these for free. So if your environment is already using Azure, it's in public preview. There's nothing blocking your company from trying this out, right? You get 15 hours of one particular resource level, a SKU, 8-core, 32 gigabyte memory. You get 15 hours every month. I think that's right, yeah, every month. And then you also get 365 hours of the 512 gigabyte storage solution. Okay, it's in public preview. There's lots of documentation on the web. You can go find it in the Azure docs. If you want a demo for your company or your team or you individually, I won't necessarily, a detailed demo, I'm gonna do a demo in a minute, but a detailed demo, you can contact me and I'll get you hooked up with the right people on the DevBox team so they can show you all of the capabilities of it. And so start using it today if you already have an Azure account, Azure subscription. If you don't, go get an Azure subscription. Key, if you have an MSDN subscription, you already have Azure. So please go use it. Okay, so where does DevBox land on our chart, on our scorecard? Okay, these are respectable numbers. There's a lot of numbers on here that are higher than what I gave the Contoso fictional developer environment. It comes out a total of 21. Okay, just happens to be my scorecard, but take it for what it's worth. Okay, let's do a demo. I'm running a little bit behind, so I'll try to make it fast. All right, so let me load up the demo. Okay. So what you're looking at here is the Dev Center that I set up. So what I've done is I've gone and made a Dev Center to be used for the Microsoft STL project. So the STL project, if I can get my mouse over here, respond to the mouse. So the STL project, and of course it signed me out. The STL project is the Microsoft MSVC standard, C++ standard library implementation. We open sourced it a few years ago and announced that at CppCon. And so it's not a complicated developer environment to build, but it does require you to install certain things from Visual Studio. It requires Python. It requires some Clang tools to be installed as well. Sorry, let me authenticate here. Okay, so this is the DevBox portal. So if you go to create a new developer environment with DevBox, if your account that you've logged into has been given permissions on a project, you'll see this new DevBox button over here. I was hoping this thing should have already been loaded up. Okay, so this is a DevBox that I already created, and you'll see why I've created it already in a minute. I'm going to go ahead and connect to that using RDP. So I'm going to open my RDP client and click open. Okay, so that is supposed to be loading up in the background. It'll probably ask me to authenticate in a second. Okay, it's asking me to authenticate on my other screen. I authenticated. While that's loading up, what I'm going to show you is what it looks like to actually create a new one. And my mouse has disappeared. Okay, there it is. So to create a new one, you just go New DevBox. It's going to open up tray on the right if the Wi-Fi connection will actually work. Okay, let me close that. Okay, there we go. So this is simple. You just provide the name that you want for your DevBox, and then these aren't options yet because I only have one project and one DevBox pool associated with it. But if your account is in multiple projects, this will be a drop-down and you can select. And if any of those projects has multiple pools of machines that you can provision from, there'll be a drop-down there as well. So if you notice at the bottom, it says DevBox creation can take 30 to 90 minutes. So that's the procurement time for a DevBox, right? Is about an hour, give or take some time, right? This is why I'm not going to load this one up. I already have one created. Okay. So let me pull up my remote desktop session and drag it over here. Okay, so this is my STL development environment. So what I'm going to do here is I've already cloned the STL source tree in this image, so it's already on there. I've already installed Visual Studio and all the other tools that I need. So I'm just going to launch Visual Studio. The STL actually requires the version of Visual Studio that's currently in preview. So that's a thing that someone would very easily get wrong if they were trying to set one up themselves. They might not realize that, as an example. So I've checked out the source code here. I'm going to load that up. Okay. So the important thing to know here is that this image is already warm. I've already built this in the image, right? So when the new developer gets it, they don't then have to wait for a build to even finish, right? They're ready to go right then, right? So I'm gonna show that, or prove it by switching to my CMake targets view. If my mouse can hit the right button. Okay, CMake targets view. I'm gonna right click and do build all. And what I should see is says, Ninja, no work to do. It's already built, right? But just to prove that it actually does build, I'm going to modify a file. So I'm going to do Control-T, and then I'm going to look for a file, let's just say to lower.cpp. Okay. Okay, here's my to_lower that's in the STL source tree. And I'm just going to put a static assert in here. Okay. So now when I build, I should get some build errors, right? Anybody think I won't get build errors? If I didn't, I would be embarrassed. Okay, so there we go. There are some build failures. What I expect, and it says it's a static assert. It's exactly right. I'm going to back that out. I'm going to save that again. I'm just going to build again just to get a good build. Okay, build all. So it's going and building the files because it changed. That one file changed, right? So it's doing the right thing. And it finished. And just for good measure, I'm going to run tests too, just to show that those work, because running tests is a part of your developer environment, right? So the way that you need to run tests, you could do it from the UI. I'm going to do it from here, just because I can get sort of clearer output that things are working. And then I'm going to go to the directory that got built in. I'm going to run ctest-v to run tests. And can I make that bigger? I can't make it bigger easily. So you can start seeing at the bottom there that tests are running and passing, right? So, if anyone else that didn't know how to set up an STL developer environment wanted to contribute to the STL, they could just spin up one of these dev boxes and they would just be off and running, right? Now, I'm not going to demo this in the interest of time, but I happen to know that when I built this image, the version of the source code was, it's already old, right? There's already been changes to it since I built this image. As a DevBox admin on the project, I can actually then produce a new version of the image. I can go get the latest, I can do the build, I can run the test, make sure it's all good, and I can produce a new version of the image so that when a new developer comes in, they now have a refreshed and warmed up machine to work from. Okay. That is that for that part of the DevBox demo, but I wanted to show real quickly what the portal looks like again. So this is the view that either your IT folks or that your admins for your dev projects would see. There's a thing called a dev center. It contains sort of all the things that you need. You can set up your networking connections. So your subscription will already have networking connections. You can say, I want to connect to this part of the network, right, for these dev boxes. Azure Compute Galleries are where you actually store your images that you use to construct your DevBox images. And then DevBox definitions are where you finally say, okay, I'm going to take this image and I'm going to combine it with the resources that I would want people to use, the number of cores, the number of amount of RAM to create a DevBox definition. Then especially the DevBox definitions are used in projects. So projects is then how you differentiate between this team is working on this source code, this team's working on this other source code, and they don't need to actually be able to get each other's stuff. This is the access control layer, right? So you can give a user permissions to be a user of a project, right? So this is the STL project here. Click in the right place. And so in a project, you can set up access. You can give other people admin roles for it. And you can set up your DevBox pools. That's that very bottom thing in that where we create the DevBoxes in the portal. You can set up multiple pools. One of the really good things about the multiple pools is that that's where you connect your DevBox definition with your network, right? And the network then implies what region of Azure the box gets deployed into. So if you have employees around the world, you can set up different pools for them so that their DevBox is actually deployed in a region close to where they physically are to reduce the amount of lag that they would see over the remote desktop connection. Okay. And then finally, there's a link to the portal down here if you ever forget it. It's pretty easy. It's devbox.microsoft.com. But it's there. If you need to send it to somebody, you can just copy the link and send it to your new employee. All right. That is my DevBox demonstration. So now I need to get PowerPoint back up there. Okay. And my clicker. So the second one we're going to talk about is GitHub CodeSpaces. So GitHub CodeSpaces are on-demand container-based cloud development environments. The cloud that's being used here is the one that GitHub manages. If you get disconnected, the state of your code space persists across sessions. And you have the ability to sort of go between the different SKUs. So like it's limited, but if you decide that, I started this thing with 4 cores and I actually want 8 cores, there's some ability to sort of move between different resource types as you see fit. An important part of them is that they are customized with what's called dev containers. So dev containers is an open specification. Let me pull, actually I'll pull that up when I do the demo. But it's an open specification. We'll take a closer look at that in a minute. The other good thing about the CodeSpaces is that they're built on top of Docker, right? So if you've ever used Docker, the process of creating a Docker container, right? It's based on layers, right? So it does this layer, then this layer, then this layer. And depending on how many layers you have and what kind of changes there are, they can take a while, right? It can take over 10 minutes often, right? But if you don't want your users to have to suffer that container construction period, then you can actually use GitHub Actions to pre-build those containers so that whenever your users actually want to go create a code space, it just comes up in a matter of seconds as opposed to a matter of minutes, maybe a dozen minutes. There's not a lot of slides here. I also have a talk tomorrow morning online talking about more GitHub stuff. And CodeSpaces will also feature in that. But I've got a demo that I want to show that is pretty cool, I think. So where does GitHub CodeSpaces land on my rubric, my scorecard? Okay, some different scores than what DevBox had. Some of them lower, some of them higher. But the one number that is remarkably different is the documented number. DevBox had a 0 for that, and GitHub CodeSpaces has a 4. And that's all because of the dev container specification, right? It really is executable documentation for how you create your developer environment, right? So I gave it really high score because I like that, right? You may like other stuff, but I like that. So 27, okay? So let's look at a demonstration. I've got not as much time as I had hoped, but okay. I need to minimize that, minimize that. Okay, where is my browser? Okay, so this demonstration is built on top of a project called FreeCiv. I'll make this bigger. Okay, FreeCiv is a open source turn-based strategy game that's modeled after the classic game Civilization. There's a series of games called Civilization. It's hosted on GitHub. I've already forked it here. And I'm gonna create a developer environment for FreeCiv, all right? So I've already created the code space. So I'm gonna go ahead and tell it to launch. Let's see, it was bug-free space disco. They come up with very creative names for these things. That little dialogue that you just saw, that's also how you create a new code space. You can create it on the branch you have checked out or that you have active in your web page, or you can actually configure it to check out. There's different ways you can configure it to pick different SKUs and things like that. Okay, so here is my code space. It doesn't show up. The contrast looks weird. Okay, so the first thing I'm going to do, because it might take a little while, is I am going to actually launch the build process for it, if it actually finishes coming up. Okay, so I'm going to say the build process for this, I happen to know. You run this sort of configure script. It's called autogen.sh. There you go. It's going to go do its configure. So while that's working, what I'm going to talk about is this dev container folder, .dev container folder. This is basically the folder that dev container uses to configure your environment, right? Dev container is actually an open specification. It's published here in this GitHub org. There's a spec, and there's actually a reference CLI implementation of this as well. So you're not constrained to using dev containers in CodeSpaces. You can use this CLI to actually run it on your local systems, right? It's written in NPM. It's pretty cool. And there's also documentation for what the JSON settings file looks like, right? So it walks you through what all the settings in the JSON file are, what they look like. And here's a link to what the reference implementation looks like, or how you use it and the like. Okay, let's go back to this. All right, my autogen finished working. So this is a makefile-based project. So I'm just going to run make from here. I'm going to do it with 8. Okay, while that's making, we're going to actually look at the dev container JSON file. Okay, if you want the specifics, like if you want to go into a lot of the detail about what's in here, I'm going to leave you to the documentation to do that. But there's a few things in here that I want to call out. So first off, there's always a name. This just happens to be the default name that it generates as C++. It's built on top of Docker, so you can specify a Docker file that exists in your repository to build on top of. And if your Docker file is one that takes arguments, you can provide those here as well. The next thing I want to call out is this extensions and features. I'll do features first. So features is basically, there's a set of already labeled and named features that you can sort of have applied to your dev container after the Docker process has finished, right? Sort of consider it post-processing for your Docker image. Extensions is also very similar to that, but these are, it's an array of Visual Studio Code extension IDs, right? So if you know your developer environment needs C++ tools, you can put the ID for it there. I happen to have the extension pack, the CPP tools extension pack. I have the Docker extension that we publish because, well, I'm looking at the Docker file sometimes and I like syntax highlighting. And I have the GitLens extension installed because I think it's a great extension to use if you're really using Git a lot. For the features here, I'm making sure that an SSH server is installed. And yeah, I think that's all I want to take a look at in this particular file. Let's look at the Docker file real quick, though. Okay, the Docker file. If you're familiar with Docker, this will look familiar. If you're not, it may look a little weird. Consider it as kind of like a kind of batch script, right? A kind of shell script. The particular one that gets generated by default whenever you do this through the IDE, which if you wanted to do it through the IDE, you would open up the command palette and do add development container configuration files. That'll walk you through a wizard that will then create a template of what these files look like. I'm not going to do it because I already have them. Okay, so this particular Docker file has options in it that you can actually go download a particular version of CMake. It also has options in it where if you are using the classic mode of VC package where you install things on the command line instead of having a manifest, you could do that here. I'm not using VC package for this example because the repository didn't use VC package already, and it's not the point of it. But if I did use it, it would have solved the problem I ran into. So the last thing that this does is it goes and installs a bunch of system packages. These are the dependencies that this project needs in order to build. And when I first did it, I got this list of dependencies from the GitHub Actions CI scripts that had a list of these dependencies, and I just copied them over. And one of them was the Qt5 default system package. And so I made my code space, everything worked fine. I came back later to make a code space, and I picked a different operating system platform to build on top of. Well, it turns out that that one, the system package library, dropped the Qt5 default package. And so now my Docker file wouldn't actually build and my container wouldn't spin up. But if I had used a package management system like VC package, I wouldn't have had that problem because it goes and gets the source code and builds it, right, locally, right? Just something to know about. Okay, so it looks like it finished building, right? So it finished building, what should I do next? Maybe I actually want to run the things, right? Okay, so let me try to run the GUI client for it. Does anybody know what's going to happen when I try to run the GUI client? Nobody wants to guess? Okay, I'm going to type in, I've got to do one more thing first. I got to do sudo make install. I don't have to, but it makes it a little easier. So this actually just copies the files that I built into the normal locations that are on path and everything. Okay, FreeCiv, it's a GTK client. So, okay, I don't know, it may be too small for people to see it, but basically what it says is it did a lot of startup stuff, and then it says, cannot open display, and then it ends. And the reason why is because this is a headless VM running a container, right? And on Linux, to have a GUI, you need some sort of server running, like an X11 server. But this doesn't have a place to show that, right? But we can solve that problem. So what I'm going to do instead is I'm going to just run the server part here. Just make sure that works. Okay, the server is up and running and ready to accept connections. I'm going to hop back over to my DevBox that I was using earlier. So this is a Windows 11 DevBox. I'm just using it because it's convenient. It's Windows 11, whereas my local system isn't. Windows 11 has the ability to actually show Linux applications that are running in WSL on that system in the Windows desktop. Okay? So I'm going to load up an Ubuntu shell on this system. Now, in order to actually make the remote CodeSpaces UI show up here, I've got to set up an SSH tunnel. Okay, but I've got to set it up to a CodeSpaces machine that lives out in the cloud somewhere, right? So how do you do that? Well, GitHub has a tool called the GitHub command line interface client. Okay, it's just GH. I've installed it here already. Okay, yep, that's right there. And I've already authenticated. There's an authentication command you can run that makes you log in through GitHub and all that sort of magic. But what I can do is I can run GitHub GH CodeSpace list, and it actually is going to show me all the code spaces that I have access to in their states. And you can see there I have one that's available, right? Well, there's a really nifty command that you can give the CodeSpace, a subcommand you can give the CodeSpace command called SSH. You can actually instantiate an SSH connection to this CodeSpace machine. Okay, so instead of doing it that way, what I'm going to do is I'm going to say SSH, oh, too far back, SSH config. And then I'm going to redirect that over to a file in my SSH config directory. Okay, tab completion, is that going to work? Oh, that's why. CodeSpaces. Okay, so it's skipping over the ones that are shut down because it can't talk to them. But it did just take a config information for the one that's active and put it in a file that I can use in my SSH config. So if I look at that file that I put that into, I can see this is sort of like SSH config language, right? This is basically saying, okay, that machine over there is known by this name, right? And I happen to have already set my SSH config file up to just include this one. So now I can just do that, and then I can use oh, that's the wrong, it's S instead of X. I can just use tab completion to get there. Okay. All right. From my DevBox system that I set up, just incidentally, I'm now connected through SSH to my CodeSpaces Linux machine, right? So just to check and make sure that the forwarding works, there's an application called XEyes, and hopefully it doesn't take long to do the remoting. Come on. Keep in mind, this is executing something on the CodeSpaces system, remoting the UI to my WSL instance in the DevBox, which is then showing it on the Windows 11 desktop on that DevBox. So this is a fun little, just test application. It just follows your cursor around with the googly eyes, right? So if I make it bigger, right, you can really kind of see then what it's doing, right? So my X11 forwarding is working. So I'm going to close that. And now from this system, I should be able to run my client. Okay, it clearly did not end like it did before with where it couldn't find a display to show on. So even though a code space is a headless environment where you can't do graphical, you can't interact with the graphics of the system, right? there are ways you can do an SSH tunnel with the GitHub tool to actually then access it. So this thing is running over on my code space, but I'm interacting with it here, which means that I could debug this thing, right, on the code space and use the use the GUI on this system to sort of drive the experience, right? So just to show, you can connect to a network game, and there's my server that's running. And I can connect. Yep, okay, so then it's there. I'm gonna start a game. And there you go. I started a game of FreeCiv that I can play and debug. Okay, I'm gonna close that. Actually, I'm gonna minimize this and show you what the code space looks like. And so you can see the code space, the server is now like, okay, somebody connected, somebody started the game, and you could just debug stuff here. Okay, that's the end of that demo. Not gonna have much time for questions, but I will make myself available post-session. Okay, that's that demonstration. So then the question is, okay, if you're considering these two things as solutions for you, right, well, which one do you pick, right? Well, things to consider, not necessarily definitive, but things to consider when you're considering both of these. If you're doing Windows development, if you're in an environment where you have corporate policies and IT wants to make sure they manage your system and make sure it's secure, if you need access to a full operating system desktop and the ability to install other desktop tools, and if you want to have really warm environments that you can just, like it's already built and compiled, right? Then DevBox might be a good solution for you. If you're, using Linux, right now, CodeSpaces is only Linux. Or if maybe the people who are going to be using your developer environment, maybe they work on dozens, maybe even hundreds of different projects, right? They're isolated enough that you can do that without them interfering with each other. If your code is hosted on GitHub, right now it's required to be hosted on GitHub. I don't think there's a plan to change that. It's a GitHub service. And you don't have to worry about IT or DevOps, like being picky about, I need to make sure this development environment is good, is secure, which means it's really good for open source stuff. Then GitHub CodeSpaces might be your solution. Okay, the last thing, we only got a couple minutes left, but the last thing I want you to take away from this is that don't just take my scorecard and my rubric and just use that, right? That was my opinions, right? We can all be opinionated, right? I encourage you to elevate your thinking about developer environments and use a structured approach to evaluating whether or not the systems you have now or systems you're considering are actually solving the problems that we all have for developer environments. Okay, but maybe your pain is more in procurement than in isolation. Right? You should make your own scorecards for these things. You can start with mine, that's fine, right? And that's the end of the presentation. So we got a minute and a half left on the clock. Everybody in the room here can come find me later, but do we have any online questions? We don't have any online questions. So if somebody wants to ask a question here, feel free, otherwise you can just find me later. My plan is to actually hang out in GatherTown, outside the Track C room some tonight. So if you have questions and you're online, if you want to find me in GatherTown outside of Track C room, then that's where will probably be able to find me sometime tonight. Okay, I guess we're done. Feel free to come get some mugs. We're not taking them back with us. So, and that's it. Thank you.